do another one. Unfortunately, we didn't get that wonderful explanation that Estrella said on recording, but we will now. So go ahead and factor that one. Okay, so all right. So the first thing I'm going to do is I'm going to factor the first one. So 2x can be factored as 2x and x. Then I'm going to factor the last one. Negative 5, or just 5, is 5 and 1. I should have done it the other way to see if it doesn't work, right? Do 1 and 5. Let's do rainbows and checks and see what happens. This gives me 1x. This gives me 10x's. Does 10x and 1x somehow make negative 3x? Not even a little bit, right? Not even close. So all I have to do is switch the places. Instead of the 5 being here, the 5 should go here. So 5 and 1. Now I do my rainbows and checks again. So this is 5x. This is 2x. Can we make 5x and 2x somehow negative 3x? Yes, we can. The difference between 5x and 2x is 3x, but if it's negative, it means the bigger one has to be negative. If the negative is going to be associated with the inner, then somebody on the inside has to be negative, so it's going to be the 5. I'm not going to make that negative, right? I guess I could. If I really wanted to, it would work out, but we don't normally do it that way. And the 2x is positive, so that means the outer has to be positive in order to make negative 3x. We just checked it, rainbows and checks. It all works out. I want to say one more thing. What are we finding? X-intercept. On your test or your quiz tomorrow, it's going to have a 0 like that. So you not only need to factor, but you also need to solve. If I set this equal to 0, what's it going to be? Negative 1. Remember, we've been doing this the whole time, right? Finding our zeros. And if I set this to 0, what's it going to be? Positive 5 over 2. Remember, divide both of them by 2. Remember that? Let me show you over here. 2x minus, guys, I'm tired of the talking behind me. I'm recording. My turn. 2x minus 5 equals 0. Add 5 to both sides. 2x equals 5. Who wants to do all this work? I don't want to do all that work. I'd rather just look at it and say, if I divide both of those by 2, I'm going to have 5 halves, negative 5 halves. The opposite of negative 5 halves is positive 5 halves. Okay, let's do another one. I have them right here, and I'm going to have to, like, move it down because I want to keep this for the recording. How about that? So factor that one for me, please. Okay, we're about, I'd say about 90% on this one. That was good. You're very welcome. No, thank you. You know what, before I go any further, I can see boxes that I have here. Let me move them really quick. I've got a box there. There's that one. And I've got a box here. And I've got a box. Can you guys see them? Where'd the other ones go? Sorry, guys. I just don't want to lose them. Okay, better. All right, guys. I need the talking to Steve, please. Pretty please? Okay, so this one, 5 can only be factored into 5z and 1b. How can 1 be factored? 1 and 1, it's the only way it can be factored. 1 and 1. Now we're going to do our rainbows and checks. Okay, I need the talking to stop. And 5v. Does 5v and 1v make 6v? Yes, it does, because they both add together. That means the inner have to both be positive and the outer both have to be positive. Let's solve. What's the solution of this one? What's the 0 here? -1. What's the 0 here? -1/5. Good. Another one? 15, 16, 14. Let's do 14. Let me make it a little bit darker so I can see them. Okay, do 14 for me, please. All right, let's do this one. This one's easiest to factor right here, the first one. So that's just 2s and s, always, right? And then this one, I might as well do it in red, right? So 6 can be broken up as 1 and 6. Let's take a look at that. 1s, 6 times 2 is 12. Is 12 and 1 going to get you anywhere? What about 6 and 1? 6, 2, is 6 and 2 going to do anything for you? No. What about 2 and 3? 2s and 6? 2s and 6? 2s and 6 can do that? You're going to have to switch them. So 3 and 2? We're pretty confident we can start doing rainbows and checks? 3s and 4s? Can 3 and 4 make 7? If they're both negative, right? So then that makes my -7s, so I can circle it. We're done. Now let's solve it. So what's this one going to be? Negative what? 3/2. Oh wait, it's going to be positive because these both are supposed to be negative. Thank you. I forgot my negative signs. So it's going to be +3/2, and this one's going to be +2. Do we have this part down? Here, can I have thumbs up, thumbs down, please? We only have a few thumbs sideways. 1 thumb down, 2 thumbs down. Okay, we'll just keep doing it. Yes. Okay, do that one for me. Oh! Philip just caught his own mistake. And Shreya, they just caught their own mistake because you can't check it if there's no middle term. How can 5p and 20p make no p? And this is what brought me to asking the kids in the last class who I had for junior high, because I said in junior high you can't use a variable of p because the kids lose it. I'm serious. Philip almost did, huh? She said p. Okay, so this is called, does anybody know? This is a special product. What's it called? Don't say it. Not binomial factoring, but I like the vocabulary. Nope. Okay, that was a wasted piece of candy, right? What? No. But that's the difference of 2 squares. Guys, whenever there's no middle term, it's because they are canceling each other out. One's a positive, one's a negative, and they're exactly the same thing. I break up the squares. So 4 is broken up into 2 squares, which is 2 times 2, and 25 is broken up into 5 and a 5. Thank you. Thank you for telling everybody to be quiet. So, when I do my rainbows and checks, I get 10p and negative 10p, which gives me no p. Then, I've got two solutions. I've got negative 5 over 2 and... So, Lucas, do you now know when you ask me, does it matter where the negative and the plus go? Does it matter? It does? Not this time, because it's the difference of two squares, right? And they match exactly. Other times it does. That's why I said I really couldn't answer you yet. Okay, now, question, Kayla. Then it would not be the difference of two squares. They have to be squares in order for it to be the difference between two squares. They both have to be squares. Okay, good question. Okay, let's do one more. Let me see, how much time do I have? Shoot. I need to do this one first. Do this one. I have a hint for you. Okay, you guys don't want any hints. Okay. We're not ready for our homework yet. Okay. So I see a 2, and they all happen to be even, so it must mean that there's a 2 in each one of them. So you always want to make your life easier and factor out a 2. At this point, you should see structure. You should see squares. I see a square here, right? The square root of 81 is 9. Oh, and 9 and 9 make 18. I'm done. How many of you saw that? Good. Yeah. So, this is actually written like this, which means how many zeros do I have? 1, which means that it's just going to swipe at negative 9, sorry, and it's going to look like that, right? And look at 162 being the y-intercept, that makes complete sense, because if I'm all the way shifted over on the y-axis, x-axis, and I go straight up, it's going to take a long time to get up there. Right? Makes sense? Sure. The 2 has to do with something with the shape, the slope of the parabola. That's how what effect the 2 has on it. Okay? All right, I have one more to do in front of you, and I need you guys to quiet down. Let me see which one I want to do. I want to do this one. Okay, everybody, pencils down. Check this out. I'm going to do this 2 different ways. I need you guys to be quiet. There's too much talking back there. Okay, I'm going to do this one. I'm going to say I see the difference of 2 squares. Very good. So I'm going to say I've got a 3x and a 3x and a 6 and a 6 and a plus and a minus. But I see more. You can factor a 3 out. Go get yourself a piece of candy. In the back, there's a basket right there. Does anybody see a different way? Anybody? Does anybody see a different way to do this? Go get another piece of candy. That was awesome. Check this out. If I would have thought that it had a common factor of 9 to begin with, I could have factored out a 9, left the 4, and now I've got the difference of 2 squares. Isn't that easier? No. All right, let's get into our lesson. Okay, so this says a tennis ball is tossed out of a window that is 4 meters above the ground. 4 meters above the ground. The position of the tennis ball is given by this function right here. This isn't a homework problem. Okay, so we don't want to break our concentration when I'm like in the zone. Okay. So I'm going to rewrite it to be negative x squared plus 4. Wait, I hear pages turning. Okay. Now, but this isn't the difference of two squares, right? This is the sum of two squares. So if I took out a negative sign, now it's the difference of two squares. So all this negative tells me is that whether it's pointing down or pointing up. X plus 2, x minus 2. So what are my solutions? Negative 2 and positive 2. Here's positive 2. Here's negative 2. Which one makes sense? The positive 2, because we don't throw in the negative direction. I guess that doesn't make any sense, right? But anyways, it's falling down, so after 2 seconds, it's going to hit the ground. Okay, so there's a real-world application for the big idea. So the only thing we're going to do that's new today is we're going to find the vertex. All right, now you guys can, oh, you can't have your homework out until Florencia, I'm going to take the whole binder away. Yes, I will. Okay. You get your homework back after I do the first example. Okay? Actually, I think I'm going to give you your homework back after I do the second example, because I like the second example better. And then we'll go back and we'll do the first one together. All right, let's start with the only piece of information I have right now. My y-intercept is at 0, -9. So I'm going to go ahead and graph that. -9. Secondly, I want to pull a negative out of there, because you normally don't factor when the coefficient is negative. All right? All this is telling me is my graph is pointing down. Okay? So we're going to pull that negative out, and we're going to ignore the negative through the entire process, except to say the fact that it's pointing down. But I'm not going to say it's pointing down. I'm going to say that the relative, it has a relative. You guys tell me, if it's pointing down, is that a max or a min? It's a max. It has a relative maximum. This was, I don't think we even really, I mean, we've covered this so in depth, they get it. So it's nice. The vocabulary is good. We were worried we have that on your quiz, that verbiage, the relative max or relative min, and we were worried because that we weren't putting it in there, but we have been all along. So you guys are good. Awesome. So I'm going to take that negative out first. So this is going to equal negative. That's going to turn this. I'm actually going to put brackets because I really want to ignore the negative for now. Don't want to concentrate on it. 4x squared plus 12x plus 9. See what I mean? Now I'm just concentrating on finding zeros. So again, I'm going to ignore my negative out here. And I see squares. You should always be looking for squares. I see a square here. I see a square here. This, the square root of 4 is 2. The square root of 9 is 3. Do you see something there? They make 6, which 6 and 6 is 12, right? See the structure? That's what you should always be looking for first. It's not always going to be there, but that's what you should be looking for. 2x, it'll save you a lot of time. So 3 and 3, this is a positive. That means these both have to be positive, positive. I'm going to do my rainbows and checks just to be sure. So this is 6x. This is 6x, which makes 12x. So check, we got that one. I'm going to erase this part, though, so that we can actually see what we're doing here. So my x-intercepts are at -3/2, right? You divide both by 2. And this one's also at -3/2. So my x-intercept is at, let's make these halves. I'm going to make every single one of these a half. So if this is a half, then I'm going to go 1/2, 2/2, 3 halves. I don't know if that's such a good idea when I've got, so this is going to, my y-axis is, yeah, I don't think it's a good idea. We're going to go just by 1, because I don't want to have my y-axis is different than my x-axis, which it can be. What do you think, Miss Liz? Is that going to be too confusing? Probably. Okay. Okay, so 1.5. Negative 1.5. All right, so my y-intercept, we said, was already at 0, negative 9. My x-intercept, I'm going to erase this so I can write that in there, is at, should I say 1.5? Would that be better for you guys? Negative, I'm going to say consistent. My husband would say, why did you ask me if you're just going to do what you want to do anyways? Right? Is that what your mom says too? Okay. Axis of symmetry. Can I find my axis of symmetry now? How do we find the axis of symmetry with zeros? What happens in the middle? Is there a middle? It is the middle. Right? So, Philip, I love the way you phrase that. What happens in the middle. That's brilliant. Brilliant, brilliant, brilliant. I just give him the whole basket of candy right now. You're doing so good. Okay. All right, so my axis of symmetry is actually at 3 halves as well. I changed my color. How are we doing on time, guys? 26? Okay, we're good. So, the newest piece of information. So we've done all of this, right? So the only new piece of information here is I'm now going to say, Danae. Thank you. I now need to find my vertex. My vertex is actually, I have half of it already, don't I? If I find a vertex, isn't the vertex always on the axis of symmetry somewhere? So if I go over 3 halves, I'm either going to go up or down at this point. What do you think I'm going to do? Is it going to go up or is it going to go down? Really? Well, look at, we have symmetry, so if we have, this is 1.5 away from the axis of symmetry, so isn't it this too? We got ourselves a really skinny graph. Does it make sense that it's really skinny or going in the negative direction at a really great rate? Why? Why is it so narrow? Why is it going in the negative direction so quickly? Yes? What's making it go smaller and smaller and smaller? I heard it. The slope. Go get yourself a piece of candy. Where's the slope? Wait, before you get the candy, where's the slope? What's causing this whole thing to go incredibly skinny? The -4. Okay, you both can have candy. I got to go get more candy. I'm being very generous today. Okay. All right, 5, 4, 3, 2, 1. So I already have the first piece of my vertex. It's at -3 halves. I want to find the rest of it. So I'm going to go ahead and plug it back in. I can plug it back in 2 different places. Does it look like fun to plug it back in here? I see 3 halves, and I see this one, and I say to myself, that looks like a lot of easier things, because look, I've got 2s and 3s, and I've got 2s and 3s, right? Wouldn't it be easier to plug it in that one? They're the same thing because they're equal. They're just in different forms. So let's use this one. So I'm going to say -2 times -3 halves times -3 halves. Do you see what's going to happen there? Plus 3. I'm going to change the color of this just because it's kind of hard to see. Let's make it black. -3 halves. And that's going to be multiplied by 2 times -3 halves So that fraction's not so scary, is it? Carrie's the only one that agrees with me, right? Okay. So I've got that cancels and that cancels. That cancels and that cancels. So I'm left with negative. Negative 3 plus 3 is 0. And negative 3 plus 3 is 0. So it's just 0. So not only is this my, is that right, Ms. Swift, on this one? Is that right? It can't be right. I thought it was like, it is right. Where do, got it. So this point is not only the vertex, it's not only the axis of symmetry, it's, did I? What did I say wrong? Oh, sorry. Okay. So it's not only the 0, it's not only the axis of symmetry, it's the vertex too. Oh, I'm not that generous today. Okay. I like how excited you guys get. Okay, so now you can have your homework and copy that one down. But I'm only going to give you guys 3 minutes because I want to get another one in. Okay, so you guys immediately said difference of 2 squares when I switched this over. And then I've got a y-intercept at -4. I've got +2, -2, so my zeros are at 2 and -2. That means I've got my axis of symmetry. It's, right? You can see like all of it. Isn't that exciting? Okay, all right, let's go to this one. It's amazing how much when you put it all together that you really know now, right? Okay, so what about this one? What should we first do? What's what we always look at? I like that you're talking about factoring something out, but I heard it. The y-intercept. Does this one have a y-intercept? It does. It's 0. There isn't one, so it's at 0. And that should have been in green. Can I have pencils down for a minute? I'm going to do a couple of them, and then I'm going to have you guys do the y-intercept on your on whiteboard. It's okay. Okay, y-intercept's at 0, 0. You guys already told me that I need to factor out not just a 2, but a 2x. Good. When I factor out 2x, I'm left with x plus 2. So I actually have, I'm done. I've already got my zeros. I've got a 0 here, which is -2, and I've got a 0 here, which is 0. If there's nothing there, 2x, when 2x is equal to 0 and you divide by 2, you get 0. So my x-intercepts are at 0, 0, which I already had one, and -2, 0. -2, 0. Now I know my axis of symmetry, right? It's at, what, x equals -1. Miss Wiz, I'm glad we spent 3 days on this like this. Is Miss Wiz here? Am I just talking to nobody? Okay. Talking to myself. So now can you guys find the vertex for me? Do it on your paper and then just write it on your whiteboard. Does this have a relative minimum or maximum? I know. Does it have a relative minimum or maximum? Is it going to be positive pointing up or negative pointing down? So would that be a minimum or a maximum? Minimum. Okay, if you want to see the answer to this, I'm going to go ahead and do the vertex right now. So if I put in -1, can you guys try and leave quietly while I'm recording? Thank you. So I'm going to put -1 back in there. And I get 2 times -1 times -1 plus 2, which is -2 times a -1 and a +2 is a 1, which is -2. I already had the -1 right here. Goes here, so it's at -1, -2. Does that make sense? It does. Have a great day, guys.